welcome to the analog communication engineering class. Here, in this session, I will explain the block diagram of communication system, and I will also explain the need of modulation or the objective of modulation. So basically, in a communication system, how many functions that is happening at the transmitter side as well as the receiver side, that I will going to discuss step by step. So this is a block diagram of a basic communication system. The essential components of a basic communication system are three. There are transmitter, channel, and receiver. This means that any communication system, either simple or advanced or analog, or you can say it is digital, must have these three blocks, that is transmitter, channel, and receiver. So first, actually, we know that a communication system serves to communicate a message, or you can say an information. Okay, this message or information basically originates from the information source. Okay, so let assume here our message signal will consider an audio signal. So first, this audio signal, that means the message signal, we are feeding to the transmitter section, the first section, that is transmitter section. Now this transmitter section mainly consists of two different subsections, that is input transducer and modulator. Okay, so the question is, why we need input transducer? What is what is its purpose? So we all know that unless the message arriving from the information source is electrical in nature, it will be unsuitable for immediate transmission. Let us assume, as I told you before, okay, here we consider that our information is a message signal, that means an audio signal, right? So a transistor, a diode, resistor, capacitor, plate, IC, all the electronics components that actually makes a communication system cannot recognize an audio signal, right? These components only recognize an electrical signal. So the first task for a transmitter is to convert any raw message signal into an electrical signal. Okay, so take suppose an example. We consider here that our message signal is an audio signal. So input transducer will be microphone. Okay, microphone converts immediately the audio signal into the electrical signal for the immediate transmission, right? Next is important section, that is modulator. Okay, so modulation in the modulator. Here we can see that this message signal, after transducer, it will become the electrical signal and then it goes to the transmitter section. Okay, so what actually modulator do? Now modulation actually happen. Now what is modulation? Now you need to remember that for modulation we are gonna need two different signal. One is message signal, another is carrier signal. Okay, so message signal is always a low frequency signal, right? So here we assume an audio signal. So what is our audible range? It is, we all know that 20 Hz to 20 kilohertz, right? So let's assume that our message signal is 10 kilohertz frequency. Okay, so it is a very low frequency signal. Now this, we for modulation we also need another signal that is known as carrier signal. Now always remember, carrier signal always must be high frequency compared to the message signal. Okay, so what actually happened in modulation? Now in modulation, some characteristic of this high frequency carrier signal is varying in according to the instantaneous amplitude of the message signal. Okay, sometimes this characteristic of a high frequency signal is amplitude, then it is amplitude modulation. If the characteristic is frequency, then it is frequency modulation. If the characteristic is phase, then it will be known as phase modulation. I will discuss every modulation later in my next class. Okay, so modulation is done. So that means we can easily understand from this block diagram that previously, first, our message signal is a raw message signal, that means a audio signal. It goes to the input transducer. After the output of the input transducer, we will get our message signal, but is in an electrical form. Okay, so it is still a low frequency low energy signal. Now it goes to the modulator. Okay, where another signal, carrier signal, is needed to make the modulation, and after modulation, the modulated wave is basically a high frequency high energy signal, that is EM wave, right? So we basically transmit the EM waves, which is high frequency high energy signal. Okay, now this transmission obviously goes through channel. Okay, so what is channels? Channel is the physical medium which connects the transmitter with that of the receiver. Okay, or we can say the term channel means the medium through which the message travels from the transmitter to receiver section. So actually, channel provide a physical connection between transmitter and receiver. Okay, so there are mainly two types of channel. One is wired channel, another is wireless channel. Wired channel example, we all see that twisted pair telephone lines or coaxial cable or fiber optic cable. These are wired channels. These channels also known as point-to-point channel, because these channels provide a point-to-point connection, right? Another channel is wireless channel, which is obviously the free space, use the free space or our atmosphere. Mostly our mobile signals all are wireless. Okay, now when the signal travels through the channel, okay, there is a signal, the unwanted signal we must say, that is always try to interfere with our original signal, that is known as noise. Remember, this noise basically always in additive in nature. We consider it is additive in nature. Okay. Now there are various kind of noise. Okay. Atmospheric noise, cosmic noise, internal noise. So there are various kind of noise. Okay. I'll discuss it later in my next class. So for now, we need to know the signal. The message signal goes to the first input transducer, where the signal convert from its raw nature to the electrical nature. That means our signal become electrical signal. Still it is low frequency low energy signal. Then it goes to the modulator, where signal modulate, and the output of the modulator, that is modulated wave, is a high frequency high energy signal. This signal goes to the channel. That channel may be wired channel, may be wireless channel, and when it passes through the channel, always additive nature noise that always try to interfere with our original signal. Now after transmitting, we need to receive and we need to retrieve our original signal. Okay, what is our intention? Our intention is whatever I transmit, that means our raw message signal, we need to retrieve our original message signal. Let us assume if our signal is an audio signal we have considered here. So if I want to transmit hello, then at the receiver end we need to listen hello. Okay, so that means we need to get back our original message signal. That's why we use receiver. So at the receiver side, again there are two main parts. These are demodulator and output transducer. Okay. So what demodulator do? It basically demodulate the high frequency signal into the low frequency signal. Okay. That means our EM wave again converted to the low frequency, low energy signal, that is electrical signal. Okay. Now still our signal is not my original message signal. It is still in electrical signal. So we need to use another section, that is output transducer. Here for our example, our audio signal example, output transducer would be the loudspeaker or amplifier, which converts the electrical signal into the audio signal again. So in this way actually a communication system basically works. Again I am repeating, first input transducer, then modulator, then it goes through the channel where noise is introduced, and again it goes to the receiver section where it first demodulates, and then an output transducer is used to convert the electrical signal into its original message signal. Okay, so this is the different sections how a basic communication system works. I'll discuss. Now next thing is the most important thing, that is we know modulation. Now the question is, why is the need of modulation? Why we will do the modulation? Okay, so first need is practicality of antennas. Okay, practicality of antennas. To understand that, we'll take an example. So for example, we consider first case 1 and then case 2. So for case 1, we will consider first that we transmit the raw message signal. That means suppose assume that our signal frequency is 3 kilohertz. So for the first case we will transmit this 3 kilohertz frequency. Okay, so what is the relation between wavelength and frequency student? Lambda is equal to c by f. We all know lambda is equal to c by f. What is c? 3 into 10 to the power 8 meter per second. And if here our frequency is 3 kilohertz, that means 3 into 10 to the power 3. After simplification we will get 10 to the power 5 meter. Now always remember, the antenna height always is equal to lambda by 4. That means it is the 1/4 of the signal wavelength. Okay, so antenna height would be lambda by 4. That means 10 to the power 5 divided by 4 is equal to 25,000 meter, which is not practical. You can see here, if we transmit a raw message signal without modulation, then my antenna height would be very high. Okay, which is not practical. Now we consider the second case where we transmit our message signal after modulation. Okay, so after modulation we will know that after modulation our signal frequency will become higher. So here we consider that our carrier signal is 100 megahertz. Okay, then our message signal, that 3 kilohertz message signal after modulation will become 100 megahertz, right student? Okay, so now we do the same mathematics. So lambda is equal to c by f. C is equal to 3 into 10 to the power 8 meter per second. F is equal to now 100 megahertz. So 100 into 10 to the power 6. So it, after simplification, will get 3 meter. Now what is the relation between antenna height and wavelength? Antenna height should be is equal to 1/4 of the signal wavelength. So antenna height is lambda by 4, which is in this case 75 centimeter, which is very much practical, right? So here we clearly see that modulation is needed for practicality of antennas, right? Now next need is interference. Okay, next need is interference. Now see for an example, if I say, okay, there are three people, those who are sending voice signal, okay, or you can consider three stations, those are sending transmitting signals, okay. Now let us assume all three are transmitting at same frequency 20 kilohertz, okay. Now when we said these three different signal, they will what happen, interfere with each other. So it is impossible to extract the original signal. So by modulating process, we can be able to transmit that in some other frequency. For let assume for the first case, we take a carrier frequency of 1 megahertz. For the second case, we take a carrier frequency 2 megahertz, and for the third case, we take a carrier frequency 3 megahertz. So obviously our modulated signal frequency will be different, and they will not interfere with each other, okay. Or we can simultaneously transmit all these three different signal now. So it is clearly visible that using modulation we can avoid interference, okay. So this technique is basically known as multiplexing technique. There are three different types of multiplexing: TDMA, time division multiplexing, okay, FDM, frequency division multiplexing, and CDMA, code division multiplexing access, okay. So these are different multiplexing technique which we do modulation, by which we can reduce interference of the signal, different signal with each other, okay. So this is the another need to avoid interference. Then narrow banding. What is narrow banding? Suppose a broadcast system intend to transmit a signal within a range 50 hertz to 10 kilohertz, right? 50 hertz to 10 kilohertz. Then the ratio of the highest to lowest wavelength is 200, right student? Okay, so for this we need an antenna which can operate for a bandage ratio 1 to 200, which is practically impossible, okay. We cannot change our antenna height uh, uh, um, for different frequencies, and the antenna height ratio is 1 to 200, which is practically impossible. So therefore we need modulation. After modulation, our signal frequency will become 1 megahertz, then the ratio will become 1 to 1.0, which is approximately unity. That means the same antenna will be used for the entire band, that is 50 hertz to 10 kilohertz. So that is another need of modulation, that is known as narrow banding. This is the third need. And the last one, the noise reduction, okay. Now noise reduction, to understand the noise reduction, we first need to know the SNR, signal to noise ratio. What is SNR? SNR is signal power by noise power, okay. So for channel capacity formula, we know that C is equal to B into log 2 1 plus SNR, where C is channel capacity, B is the signal bandwidth, and SNR is the signal to noise ratio, okay, which is the parameter of the quality of the system. Okay, we always need a less we need a signal to noise ratio. Okay, so that means we need a higher SNR. Okay, so now here SNR, from this formula, channel capacity, what is channel capacity? It is the maximum achievable information rate that can be transmitted over the channel. Okay, that will be transmitted over the channel. So from here we can determine that SNR is equal to 2 to the power c by b minus 1. That means if b, that means bandwidth, increases, then what happens? For a fixed noise level, that means if noise level is fixed, then corresponding signal power is increases. Okay, that means our signal quality become improved. So for the more bandwidth, obviously we need to require modulation. So there are four needs. Okay, first and most important need is practicality of antenna. Second is interference, avoid interference. Third is narrow banding, and fourth is noise reduction. Okay, so this is all about of the today's class. We'll discuss the modulation technique in our next class. Okay, thank you.